Okay, so in this video, we're going to talk about acids and bases, and this is the last concept we will cover that will be on our fourth 9 weeks test. Our fourth 9 weeks test will consist of all of Unit 8, which is on solutions and acids and bases and molarity problems. Alright, so as you go along, you should have guided notes that goes along with this video. So you should be able to fill in your blanks there as we talk about this stuff. Alright, so acids. I know you've all heard of acids before, and what they actually are is compounds that break up in water to give off H plus ions. Now, what is H plus ion? That is, and I would write this in, those are hydrogen ions. So they give off H plus ions, and they're also compounds that accept electron pairs. Now, one example of an acid is H2SO4, and that is sulfuric acid. That's a very strong acid. If you get this, a concentrated sulfuric acid on your skin, it will definitely, burn your skin. Now, what it means by giving off hydrogen ions, if you were to put sulfuric acid in water, it's going to disassociate into its ions. So you have H2SO4, you would have hydrogen ions in here in the water, and you'd also have sulfate ions, which sulfate, remember the sulfate ion had a -2 charge, and you'd have, sulfate ions all through there also. So that's what acids do when you put them in water. Now, some common acids is HCl, you have hydrochloric acid, that's what's in your stomach, helps you break down food. You have H3PO4, which is phosphoric acid. You have acetic acid, which is HC2H3O2, which the common name for that would be vinegar. Then you have the ascorbic acid, which is H2C6H6O6. All right, that's like in an orange. If you notice something about all of these compounds, they all begin with hydrogen. One way you can tell if something's an acid, and this isn't the case for every acid because not every one of them start with hydrogen in the front of them, but the big majority of them, if the first element in the compound is hydrogen, more likely it's an acid. If you have like H2S would be hydrosulfuric acid. If you have H2SO4, that's just sulfuric acid. If you have H2CO3, that is carbonic acid. All right, so always look if you have hydrogen in the beginning, then you're dealing with an acid. All right, so some properties of acids. They contains at least one hydrogen atom that can be removed, usually at the beginning of the formula. It releases hydrogen ions in water, which we already said that. And what forms an acid in water, it forms the hydronium ion. So make sure that you know that. H3O and then a plus, which a plus without anything is just a +1. It forms and that's called the hydronium ion. Now, they taste sour. Hopefully you're not, tasting any strong acids, but that if you taste, like an orange or something that has a little bit of a sour taste, they can neutralize bases. What that means is it can bring a base's pH to neutral. We'll look at that again here in some more detail in a minute. And they are corrosive to metals. They react with metals to form hydrogen gas. So if you notice this, if you have zinc, one of your reactants on the left side of the arrow reacting with HCl, which is hydrochloric acid, the products will be zinc chloride and hydrogen gas. So when they react with metals, they always form on the right side hydrogen gas. Now bases are the other, right the opposite of acids. They are compounds that form OH ions when placed in water. What OH is, and I would write this down, you need to know OH is the hydroxide ions. You might remember that from when we used to name compounds. So write that in there somewhere. Those are hydroxide ions. And they are compounds that accept hydrogen ions. They are compounds that donate an electron pair to another compound. And an example there would be ammonia. Ammonia is NH4OH. Now if you notice, in the formula of all bases, you're going to have a hydroxide ion. You're going to have that OH in there. So if you have aqueous ammonia, which means it's dissolved in water, what would happen is it's going to form OH ions. The NH4 is going to split off from the OH. You're going to have NH4, which is a +1 ion. That's the ammonium ion. You're going to have these ions floating around. And you're also going to have OH ions, which OH is a -1. You're going to have those polyatomic ions floating around also. It disassociates in water. Now, some common bases is like KOH. If you notice, it's got the OH in there. That's how you know it's a base. Potassium hydroxide, which is in soap. So, MgOH2, magnesium hydroxide. It's got the OH in there, NaOH. Sodium hydroxide, it's like in drain cleaner. Baking soda is sodium bicarbonate. That's one of them that doesn't have OH, but most of your bases are going to have the OH in there. All right, and if you notice, most of your bases are in cleaning products. Now, if you know, of course, soap is going to have to be something with a very like weak base, because if there's a strong base, it would irritate your skin. Of course, some stuff that's cleaning products you use in your bathroom, you want to use on your skin, or it would irritate your skin. All right, so some properties of bases is they produce OH in solution. It usually has OH in the formula. It exists as a crystalline solid when it's not dissolved. It tastes bitter. So, acids taste sour, so bases taste bitter. And they can neutralize acids. If you mix acid and base together, if you mix like I had an acid, you put a base in there, it's going to raise the pH and bring it to a neutral pH. And they feel slippery. Now, some properties of acids and bases. Both form electrolytes in solution. Electrolytes are a compound that breaks apart in water, producing charged particles or ions that can conduct electricity. Both are corrosive to skin and body tissues. And it really depends on the strength of the acid and base. If it's really corrosive to your skin, it can irritate your skin. Strong bases and strong acids will, irritate your skin. But, a big part of our chemicals are either acids or bases, because, not near as many chemicals are considered neutral. They're considered either acidic or basic. Now, in neutralization, what this actually is when equal amounts of acid react with a base, they form a salt and water. So it's a reaction. If you mix acid and base together, it's going to neutralize and bring the pH to 7. And if you notice, your reactants are acid and a base. That's on the left side of your arrow. On the right side is your products. And the products are always going to be a salt, some type of salt, and water. So some definitions here. A salt is formed from the reaction of a strong acid with a strong base. An indicator is something that changes color in the presence of an acid or a base. And you can tell if something's acid or base by using indicators. And then antacid is bases that are used to neutralize acid in the stomach. Now I know some of you have taken an antacid before for having stomach problems, and they're always bases. So bases are used a lot in cleaning products and in medicine also. And the reason is because you have hydrochloric acid, you get too much acid in your stomach. If you put a antacid in there, a base, it neutralizes that acid and causes the pain to stop. Now, a measurement of the hydrogen ion concentration in a substance is called the pH. And we have the pH scale. And the pH scale goes from 0 to 14. Now, a low pH, less than 7, means you have a high hydrogen ion concentration. That means it's an acid. Now, the lower the number, the more acidic something is. So, lower pH means stronger the acid is. You need to know that. So you see on here, sulfuric acid has a pH of about 1, which is real strong. Vinegar is about a 2. Coke is about a 3. And Coke, we drink those all the time, but people have, showed you before, you can pour Coke on a corroded battery, you need to eat the corrosion out of there. So it's probably not good for our stomachs. Bananas are slightly acidic with pH of 5, and your milk is a pH of 6. And then you have what's neutral. 7 is something that's not an acid or a base. 7 is right in the middle. Example is like, pure water. Blood has a pH of 7. Some, blood, I think there's, sometimes blood, they say have a pH of 8. And then your bases, the higher pH, greater than 7, means a higher OH concentration, and it's a base. And the thing about it is, the lower the pH is a strong acid, the closer you get to 0, but the higher the pH means you have a stronger base. So it's right the opposite. So the higher pH, it means you have a stronger the base. So if you notice, sodium hydroxide would have a pH of 14. It would be a stronger base than toothpaste that has a pH of 9. So as you get closer to 0, stronger the acid. Closer to 14, though, stronger the base. Now, litmus paper is a tool for measuring pH. You probably used this at some point in one of your science classes in the past. But it's a tool for measuring pH. The paper is placed into the substance, and if the paper turns red, you have an acid. And like I said, less than 3 is a strong acid. If the paper turns blue, it is a base. And higher than 10 is a strong base. And it shows you on this chart right here, as you go closer to 0, the stronger the acid. Neutral is 7, and as you get to the bases, 8 through 14, but as you get closer to 14, it's the stronger the base. And that's all the notes that we're going to have on acids and bases.